really excited to introduce our next speaker, or set of speakers. Jana Saadi is, actually you began your journey here at MIT like 9 years ago. It's hard to believe, but she began her journey here as an undergrad in mechanical engineering. And she found herself in Maria Yang's class. I don't know how many of you have taken that class, probably half of you. It's about toy design. And she took that, seems to be a transformative class for you, because now she's gone full circle. And she is in Maria's lab called Ideation lab, where she's working on AI processes, or AI tools for early design stage processes. So she's joined with Maria, of course. And Maria, I have to read your titles. There are so many. So I don't know how you do it. But Maria Yang is a professor here at MIT. She is a professor of mechanical engineering, associated dean of engineering, and she's associated director of the Morningside Academy for Design. And the two of them, they're going to talk about generative design tools. So please welcome both of them.
We get two mics. Hi. So I'm very excited to introduce Jana Saadi. She's an amazing designer and an amazing researcher. I mean, she thinks about how people design so that we can understand how they design so we can help them design better. That's really what she does. And I will also do a quick poll. How many people in this room design things at all? Yes, lots. I knew that was a ringer question. But the question, how many of you use computational tools like CAD or Rhino or any of those things? So you have, so good. So I'm just trying to sort of prime that a little bit before Jana does her speech. So, okay, all right.
Thank you. So I'll be talking on my work with generative design tools that I did during my year as a fellow in the Morningside Academy. And as Fava had said, my journey in design here at MIT really started with a lot of hands-on classes that introduced me to this traditional human-centered design process, where it's very hands-on. You're sketching, you're iterating, you're making physical prototypes, you're testing with users, and you're making, it's very product-driven. You're making either a physical product or a service, and it's led by the human designer. And I personally very much enjoyed being that designer that was leading the process and really making these products that could be very impactful for people. And it wasn't until Maria actually poked me towards this direction of computational design tools that I started looking more into this direction of generative design. And these tools are being introduced more often, and it's more about this collaboration between the human and the AI in the design process. So I started off first by looking at products that were created using generative design tools. So you'll see an example of them here. On the top left, you have the airplane partition made for the Airbus airplane, which was optimized to be lighter weight, and it's significantly lighter than its original counterpart, which you'd imagine for an airplane is amazing in terms of the amount of fuel that it's able to save. Next to that is the Volkswagen tire hub, which was optimized for strength, of course, because it's a part of a car. But it also took into account aesthetics. They were really trying to make it this nice, symmetric, like kind of star-shaped design. Below that is the New Balance shoe insert, which is actually specific to your own foot map. So they take the pressure of your foot, and they'll have a denser lattice structure in places where you need more support. So really open this door for this more customizable, individual generative design. And then finally, next to that is the Volkswagen Music Building, which was optimized for acoustics. So it took into account lighting and sound and all those things for their music hall. So you can see really here the examples of the potential of generative design to create these higher performing designs that have like this very specific or very new visual aesthetics. It generates them very quickly, and it generates a lot of them, much faster than what a designer is able to do on their own. And they're very complex. So it's often something that's more complex than an individual designer is able to do. These tools are starting to be adopted more in research and industry, but it's not yet super widely adopted. And what I had started to realize while looking into this is a lot of the research is about the development of these tools and trying to make them better, but we don't quite understand how they're used. And so that's something that I was interested in understanding more in my own research, and trying to see how the use of these generative design tools can affect the design process, the designer's behaviors, and their design outcomes. Like I said, they're becoming to be used more in the future of design, and I think it's super critical to understand the impacts that they have in the design as they're becoming more commonly used. So I did this by conducting interviews of designers that use these generative design tools in their own work to try to understand their process and using the commercially available generative design tools. So I'm actually just going to walk through a quick example of this process. So here there's an example of a GE engine bracket done with Fusion 360's generative design tools. And it's actually just the example that they have a built-in tutorial, so you can actually go home and try this out for yourself. So you start off with a CAD model that typically will introduce some, all right. So I don't know if the video is playing, but anyway, you'll start off with this CAD model, which you'll see here, and it's typically to be able to give some geometry considerations or constraints. So over here, you'll like, for example, start selecting some of the geometries you need to keep, often for like assembly purposes. So these bolts that you have on the edges here. So like these geometries, so you can actually put in the bolts, and then other geometries where you want to make sure that they're like the keep out zones, so they're places where you actually need to put the bolts through or things like that. So all of these like inputs to the tool, you can also put in things like their forces that you're going to have to be able to withstand, the manufacturing methods, your safety factors. So all of these inputs into this tool. And often these tool inputs are decided by the designer, and a lot of their intuition and expertise goes into this process. So for example, how do you know which bolt to use? I don't know, in the past we've used the 1/2-inch bolt. It's worked, it hasn't failed me, so I'm just going to keep on using that. So really the designer's intuition in defining the objectives, parameters, and constraints goes into this process of into the generative design tool. And from that, the tool will generate a whole bunch of designs. And they're quite a lot, and the designer will go through these results, and they'll iterate on the parameters and constraints. So often you'll have these results, and it's almost never that the first time you use the tool, you'll get the perfect design. You'll always end up with something where, I mean, you can see over here, my first iteration, I have some really chunky designs up there, like what was going on over there, and I realized, oh, I forgot some forces. So you go back and you iterate on your design, your constraints and parameters, and you kind of keep going through that loop until you're finally happy with your set of results. And then finally, you select from the results that come out once you're done. And again, this selection can be quite a task on the designer. They're really balancing all of the objectives, both qualitative and quantitative. So what you're able to actually tell the tool and maybe things that you're not. So for example, we're optimizing for weight over here, so we want a lightweight bracket, but I might actually select one that's slightly heavier because I know it's easier to manufacture or something like that. Or maybe it just looks cooler and I just really liked how it looked. So there's that selection again where the designer's intuition comes into play. And then there's a level of refinement that can happen afterwards, where it's either could just be like simple refinement, like kind of smoothing out some surfaces, or it could be something that's more intense, so like a much larger redesign. So this is the process that I just described in diagram format, and I think what was cool is that through all the interviews that we've done, despite the different backgrounds of the interviewees and the types of tools that they used, this high-level process is something they all went through. And as you can see here, it's not a simple linear process. It's not just like use the tool, magic button, your perfect dream design comes out. There's a lot of collaboration and dialogue between the designer and the generative design tool that has to happen. And I think that's what I was trying to do with my own research, is really bringing out this process and understanding more systematically how the designer interacts with the tool and what the implications of using these generative design tools can have on the research, on the design process. So I'll leave you with 3 main implications. The first is that it's a very different way of thinking. As you saw in the beginning, I wasn't really thinking about how I wanted the bracket to look. I was thinking about the constraints. I was thinking about like, what are the geometries I need to have? What are my forces? So it becomes this very constraint-driven design. And designers become designers of constraints rather than designers of actual physical shape of the objects. So as one of the interviews we had mentioned, kind of called this the ability to have an abstraction of your goal, to really understand the constraints and not care about the shape anymore. Secondly, it's still very much a human-driven process where the generative design is a tool that the designer can use, and they can use it in very creative ways. Some of our interviewees kind of mentioned how they would use the generative design as just to give a set of inspiration and then maybe do a bit more traditional design afterwards. And it just really opens the door for the type of designs and creative designs that you didn't really think to make on your own, because it gives you so many results in the end that you can kind of map this whole space of cool designs and then use it more creatively in your own work. And then finally, it also really offers this learning experience. So here is actually my first attempt at making a bookend. And as you can see, it was a very poor attempt. I think it will not quite work. It'll just fall over and it won't really hold any books. And almost immediately when I saw that design, I realized, oh, where the center of mass is a constraint I have to pay attention to make sure it doesn't fall. So as soon as you start doing this, you realize, okay, if I were designing this bookend in a more traditional way and like sketching it out by hand, I would have intuitively made sure that it didn't fall over. But by using this generative design tool, I was able to pull out that constraint and understand more thoroughly what the constraints are in the design problem, how they relate to the design geometries in the end, and what the potential solution might look like. So once you go through all that, you can get a much better bookend. Someone online did that. I haven't even reached this stage yet, but you can see it takes some time. It takes some learning, and it's this trial and error iteration that helps you build this understanding. But I'm quite personally excited about the potential of using these generative design tools in design, especially in early stage ideation, to get a better understanding of the design problem, what the constraints are, how they influence the shape and the geometry, what the potential solutions might look like, and how you might use that in more traditional design spaces. But I do think that our design education will have to change in order to incorporate these design tools. Like I said, it requires a very different way of thinking, and so this is something that we'll have to be trained about more in our design education curriculum. And I think we also have the responsibility to make sure that we're using them to design very sustainably. Like you saw, a lot of the designs, they can be very complex, and they can really open to higher performances such as lighter weight and very strong products. So using these tools to our advantage to make sure that we're really pushing the bounds for how we can design very sustainably. And then finally, making sure that we still do all of this while designing ethically and justly with everything. So making sure that we're aware of the biases that the tools bring, the biases that we bring as human designers, where the tools fall short, and how as human designers we can check them. And just making sure that this collaboration between human designer and AI is done in a very just way. We're still having a very human-centered process as we move more forward into this future of design, of using these types of generative design tools. And I hope through this you saw the exciting opportunities that generative design has in pushing our design potentials forward. And I'm happy to take any questions after a discussion with Maria.
So thank you, Jana. I really, I'm very excited about that work, and you've done such a wonderful job. And I think it's really important right now because we're at this time where you have all these sorts of tools and all things happening, and there's this maybe very romantic notion that you're just going to push a button and then magically you're going to get this perfect design. But what your work really shows in a very systematic way is there's a lot of workarounds and things that people do that still are fundamentally designed, but maybe redefined in what we do in the future, right? So are we all constraint designers? I don't know. So I have my little list of questions for you, if you would like to, if you don't mind sharing. So there is a new piece of software that you might have heard of, maybe you have too, it's called ChatGPT. Yes. So what do you think? What do you think these sorts of new software sort of approaches of AI that is so pervasive and uses deep learning and large language? How does this kind of work fit into that world?
Yes, well, so I actually started this project before ChatGPT became famous. So we were the cool kids before it became cool, and I think ChatGPT, as you can kind of see the process that I described, as I see people using ChatGPT, I kind of see the same parallel process happening. So I don't know if anyone here has used ChatGPT, but it very much becomes something where what you give it is very determining of what that comes out of it. So you're kind of designing for constraints in that sense. Like, how are you constraining the tool in the ways you're giving your input to the ChatGPT and the types of outputs that you can bring? I think in terms of design, ChatGPT, it's right now it's very much based on text. So I think in terms of like the hardcore product design that we do, it won't really give you like a physical design outcome, which is something that the tools that I studied would actually be able to do. But it is good at some things, like for example, writing software. Again, it's something that, so if you're trying to design an app, you very much could do that in ChatGPT, but it's something you still have to make sure that you're checking and making sure like it can give you the wrong thing. So if you just kind of take its word for like as perfect code, then you could very much end in making an app or some type of software that's not quite what your intention was. So making sure again that we're checking our work and while using all of these tools. I think it has that potential, and I think the fact that a lot of people are loving how ChatGPT works is kind of an indication where if you looked at the other tools that maybe do things like ChatGPT but in different atmospheres, you'll see that they're very exciting and you can definitely use them in other spaces.
That's great, thank you. I have another question for you around design, not just sort of the ChatGPT world, but more when we think of design, often we think of design being desirable and beautiful and visually appealing. And you kind of referenced that in the Wheel Hub design, and also there's lots of researchers at MIT that think about like Caitlin Mueller's work comes to mind. Could you say something about how the role of visual design and qualitative aspects of design fit into these sorts of tools?
Yeah, absolutely. So I studied mainly commercial tools, which I would say don't have direct input for like controlling visual design or aesthetics. So from the people that we interviewed, they actually all mentioned an attempt to control the aesthetics or trying to really select and refine based off of a desired aesthetic. But they all did it through their own unique workarounds. So maybe someone was like, I wanted this beam to be thicker, so I made my forces heavier so that it can be a bit thicker. So trying to be creative in how they controlled the outputs, which comes through an understanding of the tool itself as well, and like the design problem. So knowing that this force is what's going to make this beam thicker. So again, kind of that iteration that really helps with the learning of what the constraints are, and how they all affect the design outcomes. It's still very much something that designers themselves are interested in. So like these tools, they're very quantitative. They're very much focused on the numbers. But the qualitative aspect is very important. And that's where the designer comes in. So the designer is really trying to control the parameters and constraints. They're refining the product afterward to really bring in that more qualitative aspect. And so they're the ones balancing a lot, the quantitative and the qualitative, to bring this beautiful aesthetic that they were trying to go for in the design.
So actually, how are we doing on time? 2 minutes. Okay, I have one more question for you. So, we're all people who think about our students or educators, and we think a lot about design in that respect. How do you think these tools affect the way designers learn to design? Right? If you can just push the button, and then how do you?
Yeah, I mean, I said, I think it's a whole different way of thinking, and that's maybe part of why it's not so super widely used, is because a lot of us aren't trained in using these generative design tools. I personally never used it in any of my core curriculum at MIT, despite having been here for 9 years. So there are some courses, but it's not really taught in the core curriculum. And so that, like, being able to expose yourself to all of that work and build that understanding of, I should be thinking about things in a different way. And I think it's important actually and critical for students to be doing that in the classroom, where it's okay to fail. And it's better to do that there than it is to do that in the real world, where there's actually a lot of companies who are trying to incorporate, especially after ChatGPT, everyone's coming, like top management's coming down to the developers and saying, hey, someone incorporate AI into our work. And everyone's like, well, I don't know how to do that. So making sure that we're actually learning how to do that in proper ways, and like not just taking the tool, again, not taking it for granted, knowing how to use it to check its work and making sure we're designing responsibly.
Thank you.
Okay. Thank you. Fantastic. Thank you.